Hello, everyone. So I'm leading the artificial intelligence theme, and in this presentation, I will be also covering data quality theme, so that the AI theme and data quality theme is covered in this presentation because they are slightly interlinked. So I'm trying to cover them both together. So I'm representing, or we as for AI theme, we are representing Newcastle, Durham, Holland, Swansea, and QA UB. So these are the four institutions participating in this theme, and we are basically trying to set out challenges for artificial intelligence team surrounding the three aspect of the hub, which is the data quality monitoring, AI model quality monitoring. So AI model quality means the AI algorithm which is being installed on the edge devices. For example, the AI algorithm which is running on your smartphone could be one target AI model, and the edge computing environment where the data sets are being generated or where the AI models are being deployed. So these are the three dimensions of the research which is contributing to the challenges which we are focusing on data quality and AI model quality challenges. And we will be interacting with the two themes which will be presented following my presentation is the cybersecurity theme and edge computing or tiny ML theme. Uh, so they have their own research challenges, so they will be detailing on those aspects where the AI data quality and model quality challenges will be interacting is this three arrows you can see on my screen. That's where we are interacting with different themes. So for example, data quality theme and AI theme will be collaborating on how we can interlink and mitigate the challenges which we have on those aspects. Similarly, data quality and edge computing environment where cyber attacks are happening or cyber disturbance are occurring, how we can provide AI solutions to mitigate those challenges. So there will be interaction with them. And with the tiny ML research team, we will be collaborating that how we can minimize or how we can speed up the AI algorithm, how we can make AI models efficient enough to run on resource constrained AI edge devices. So there we will be interacting with tiny ML and edge computing team. So this is an interdisciplinary approach we are tackling here. For the sorry, slides is going faster. AI theme challenges are designed into three aspects. What we are going to look at. The first thing is monitoring the data quality and AI model quality. So that will be the first challenge we will be looking at, how we can monitor the cyber disturbance which is happening on edge environment, how we can monitor that cyber disturbances are impacting the data quality or AI model learning quality, how we can make the algorithms resilient enough to run on edge environment. So the first task will be monitoring them, and then we will be trying to develop strategy, trying to develop algorithms to recover the data quality and model quality on edge environment. So for example, if you have a sensor which is giving a faulty reading, or the sensors has been attacked by a cyber attack, how we can recover from those attacks the AI quality or the data quality. So that would be the second challenge we will be looking at. The third challenge would be we will be looking at how we can continue to how we can assure that the continuity of that data quality and model quality algorithm which we have developed will continue to provide that quality assurance. So that would be the third challenges we will be looking at. So these are the three dimensions of the edge AI challenges we will be looking at. And they are basically this monitoring, recovery, and assurance, these three dimensions. We are setting out different research problems. So the first research problem would be to investigate, characterize, and develop some kind of a knowledge graph or some relationship between what is happening with the data quality problems and AI model quality problems. And once we understand those relationships, we will try to find the challenges, which are how we can assure the data quality and model quality in the view of the faults, missing data, hardware failure, sensor degradations, and so on. So those parameters we will be taking into consideration and how we can provide the solutions for that. the research problem under the data quality and model quality recovery, we will be trying to develop algorithms to certify certify the data sets or certify the AI model for its robustness, that it will withstood to adversarial attacks, cyber attack, hardware resource failure, and hardware limitations, and so on. We'll be also looking at the AI model quality with respect to the cyber disturbance, cyber attacks into the federated and distributed edge computing environment. So for example, several devices collaborating together to make AI model robust, which is happening day to day. Like we are the user of smartphones, and each smartphones are basically generating data, and the AI algorithms in our smartphones, they are contributing to the robustness of the larger model, for example, in the server of Google's and Facebook and so on. So that we will be looking at cyber attacks and cyber disturbance challenges in this respects as well. And the final research problems under the assurance is that how we can continue to assure the AI model will preserve once we have deployed the AI algorithm, the edge environment, or how we can at least monitor the distributions of the data, which is once the model was trained is being sifted, and we need to perhaps retrain, or the AI algorithm will be self-adapting to the changes in the environment. So that would be the final problem we'll be looking at. So we try to start our research through our test bench, which we already have in Newcastle, which is called Newcastle Urban Observatory. It's a starting test bench for us to test our hypothesis, our research problems, and so on. So this test bench, Smart City Test Bench, has billions of smart building observations, 500 CCTV camera across the city that is giving us 24-hour real-time image feed. So we can actually observe the city, and we can deploy our algorithm to make meaningful hypothesis verifications for our algorithms. In this test bench, we have 10 billions of observations, 10,000 observations coming on minute. We have weather data. This test bench has 65 different variables across different sensors and different parameters we are monitoring, like air quality, the cars, for example, in this case, you can see, and so on. So that test bench is a very robust test bench for testing our algorithms. We have already experienced, for example, the data quality challenges in our test bench, that the sensors are degrading over time. So how we can ensure that AI algorithms working for these sensors are working perfectly. There are anomalous values coming out from the sensors. The data go out of a range, out of distributions for AI algorithms. There are uncertainty into the data. The data stream have challenges there, API failure, network failure, and so on. Cybersecurity problems are obvious, that we have adversarial attacks. So we have denial of services, spoofing, and several other types of cyber attacks happening on those IoT systems, Internet of Things sensors. There are failures of the hardware. They are obvious. So how we can make AI algorithms robust enough to withstand these failures. So these are the challenges we already experience from our test bench, which we'll be trying to resolve through this hub. So one example of data certification, or we call it safe ML. So for example, you can see that AI algorithms are being trained on the data sets we receive, like custom data sets we have in-house, and we train our AI algorithm. But in reality, you see that the data sets, they really differ. For example, and this funny example of the dogs being hanging, so which is AI trained algorithms have never seen them. And so in reality, the testing of these algorithms will fail. And similarly, in the case of autonomous vehicle, we have a range of data sets which AI algorithms are trained, but in reality, the environment is highly dynamic, and the situation for driving will change from second to second. Like for example, a moose coming in front of your car, which is AI algorithm perhaps never seen, or the weather suddenly change, and so on. So the situation for AI algorithms is very challenging. So we will be trying to work on developing algorithms which will verify our data set that these are the robust for training AI algorithms which can operate in reality. Our colleagues in Hall, they are already working on different frameworks. So we will be using that framework to start working on edge AI or in the distributed and federated learning environment. One example here I can show you is about the model certification. For example, AI algorithms, so which are for example in your autonomous car is trained on images, and suddenly the images are being manipulated. For example, somebody who is you might experience while in the city that the traffic signs are being posted by graffiti and stickers and so on. So those slight changes in the images can fool the autonomous vehicle to classify things differently. For example, a pedestrian could be classified as a speed limit change sign. So this could happen when there is a changes or slight variation in the images or the data which is received by AI algorithm. So how we can make AI algorithm robust enough to correctly classify what it should do in the event of a cyber attack or in a physical attack which happens to the environment. So how we can make algorithm robust. So there are plenty of research which we have already done, and we will be continue to making our algorithm robust enough to withstood these attacks. So the edge AI algorithms. So one example here, I can see the large scale or scalable situation. For in this work, we have used CCTV camera to monitor flood. So flood is a severe things in the UK or very critical stuff to monitor. In this case, the CCTV cameras are feeding us the data, and we can develop AI algorithms which can monitor the changes in the flood. And this example is a scalable example where this could work across the UK wide. So our solutions could be deployed on a large scale systems as well. Then we have healthcare system. We plan to also work on the healthcare. So our algorithms, which could we will develop, which will preserve the privacy, transparency, and also would be robust enough to classify unknown tasks. So if there are unknown tasks, our edge AI algorithms could be able to deal with the unknown examples as well. So that would be another challenge we will be doing in this edge AI hub. Finally, we will be looking at several dimensions of edge AI safety. So scalable oversight, self-exploration, robustness to the distribution of data, avoiding negative side effect, avoiding reward hacking, and wireheading. So there are several dimensions of edge AI safety we will be considering while developing our algorithms, for data quality, AI model quality, and so on. So we will be looking at that as well. With that, I will thank you for listening. Any question, I'm happy to answer.